Okay, so let's go and get started. Today we're going to talk about another normal form called the Greibach normal form. And the Greibach normal form, like other normal forms, well, let's just go and get into the thing here. So as a reminder, a normal form is a kind of a structural form or a syntactic form for representing something that places restrictions on the format without restricting what can be represented. In other words, we're going to take a context-free grammar, we're going to manipulate the productions without changing the language into some format, and that's going to prove to be useful. So the one we're going to look at today is Greibach normal form. If you remember, last time we looked at Chomsky normal form, where every production is either a variable producing a terminal, single terminal, or a variable producing two other variables. And that was nice to put things into that form, because then any context-free grammar, we can put it into Chomsky normal form. It'll map perfectly onto a binary tree structure. And that can be useful for proving certain things. It can be useful for programming something that keeps track of the syntax of the parse tree that was used for some particular derivation. Now, Greibach normal form is a little bit different, so let's take a look at that. So Greibach normal form, the first thing is that there's only one form of productions. For the production. So all the productions have to fit this one form. Variable produces terminal followed by something else, which is zero or more variables. So in other words, there's always a single terminal first, and then maybe no variables after it, maybe some variables after it, but every single production has to be in a form like that. So in other words, every production on the right-hand side has to start with a single terminal and only have that single terminal at the right-hand side. The rest of it can be a string of variables. The only restriction this places on the language is that lambda cannot be in the language. But we can do the same thing. It's the same restriction we had for Chomsky normal form. And we can do the same thing by taking a grammar that has lambda in the language, separating that out into start production produces lambda or S prime, and then S prime, we can put that into Greibach normal form. And we can do that with any grammar, any context-free grammar. All right, so let's take a look at the conversion process. And the conversion process basically has 4 steps to it. And we're going to go through this. We're going to take a little bit of time talking about this conversion process. And then what we're going to do is we're going to go through an example and put all this into practice. And we'll see that example kind of worked through this process. So don't worry too much right now if this seems a little hazy. This looks like a lot of kind of notation. Don't worry about that. It'll make sense here in a little bit. So step 1, convert to Chomsky normal form. So if you remember how to do that, we basically have to get rid of all useless productions, all unit productions, all lambda productions, and then we have to make new variables for every one of the terminals. So T sub A, T sub B, and so forth. And then we need to substitute those into the right-hand sides of all the other productions that have terminals in them, at least more than one terminal in them, or terminal, anything other than just one terminal in them. And then we have to any one right-hand side that now has more than 2 variables in it. Of those ones, we now need to separate those out. So at the end of this converting to Chomsky normal form, we'll have everything where it's a variable producing a terminal or a variable producing 2 variables. Now, step 2 is to relabel all the variables in this kind of sequential form, A1, A2, and so forth, all the way up to A sub n for every variable that's in V. And we're going to start with the start production being A1. So S is going to become A1. And then if we have other variables, we're going to just label them sequentially. And the reason for that is this is creating a hierarchy of them, or a sequential representation for them. So we can always make sure that a higher number in the sequence, or a higher number in the sequence follows the lower numbers when we produce these things. And that's going to be important to the process later on. The next thing we need to do is manipulate all the productions to get them into one of these 3 forms. Some A sub 1 some number. So for example, A sub 1 produces A sub 2 followed by alpha, and alpha can be a bunch of variables. And this A sub j here the j has to be higher than I. So in other words, if this is a sub 1, then this could be 2 or 3 or 4. It just has to be later than a sub I. It can't be the same. It can't be ai produces ai alpha. It has to be ai produces aj, and j has to be a larger number than I. And that's preserving that kind of hierarchy or that sequential nature to it. The other possibility is ai produces a terminal followed by a string of 0 or more variables. And this has this I less than j. There's no j on the right-hand side here. I suppose we could get rid of that part if we wanted to. Let's go ahead and do that just so it's not confusing. We just want to get rid of this first clause since there is no j in that part. And then the third one is this zi produces aj alpha. Now you might say, well, what is zi? Where did that come from? And that was going to be a new variable that gets created when we remove left recursion. So it's okay to have those new variables that are no longer a variables that were in the original one. And if you remember, when we get rid of left recursion, we have to introduce a new variable. So we're going to introduce that. But in this case, when we introduce that new variable, it's going to produce this a sub j alpha just like that does up there. So those ones are okay. But if we have something that doesn't look like one of these, that's going to be a problem production that we're going to have to get rid of to get it all into this format. We're going to take a little, the next couple slides, we're going to look at this step more carefully because this is where a lot of the work happens. But once we get done with this and all the productions are in one of these three forms, we just work our way backwards from the last thing in n, or the last thing in a sub n, and any production that doesn't start with a terminal. In other words, any production that the right-hand side starts with a variable, we're just going to substitute what that variable it starts with for the right-hand sides of that. And we're going to repeat that process working our way backwards till we get down to a sub 1. And we get to a sub 1. Now, because they were kind of hierarchical in nature, we will now have everything into one of these, into one of the original forms that we want, with variable producing on the right-hand side a terminal, followed by a string of 0 or more variables. Now, because this is where a lot of the work happens, let's take a closer look at that step 3. So step 3, we want to manipulate all the productions to get them into this form. Now, to get all the productions into one of those three forms, we have to identify and fix any ones that don't fit that. And there's two types of problem production that can arise here. And those two types are, type 1 is where we have AI producing AI. So in other words, this is the same number on both sides. So that's a problem. In other words, those are left recursive productions. So if I have a production where there's a left recursive variable like that, I need to resolve that because the j has to be higher than I, not the same as it. The second one is where the j and the I are kind of backwards. In other words, the lower number happens on the right-hand side and the higher number is on the left. So that's a problem production where the ordering isn't correct. The ordering is kind of inverted. It's backwards. Okay. So how do we get rid of those two types of problem productions? We'll start with type 1. We just remove left recursion in the traditional way. In other words, we divide this up into the non-left recursive production types and the left recursive production types, and then we perform the replacements like we did previously. So here's our new variable zk. We name that the same number as the one that we had, the a that had the left recursion. So if this is ai, that's ai. We say, well, now that k is going to be I here. We put that there. And then for all of the productions that are non-left recursive, we have that non-left recursive part, followed by the non-left recursive part with a new variable. And then we do that for all y, all I of y. And then we do the same thing for all x of j with the left recursive production. So this is the same process we used to remove left recursion that we looked at several lectures ago. We just do that. Now type 2, where the ordering is incorrect, we basically just go through and say, okay, well, I have one of these productions where the ordering is incorrect. Let's take this a sub I on the right-hand side, and that's going to have its own productions with the right-hand side. We're just going to do a substitution. We talked about substitution previously as well, and so that you can always perform those substitutions and it won't change the language. So we're just going to substitute all the right-hand side possibilities for AI into the first position of this side for a sub j. And we're going to do that for all of them. And that it's possible that either of these two things will introduce new problem productions, but then we're going to handle those, and we're going to keep doing that and keep doing that until we've eliminated all the problem productions. In other words, when we're done, every one of the productions is going to be in one of those forms that looks like this. Okay, let's try an example. And this example is where I think this will make a lot more sense. So let's go ahead and do that. All right, so here's my example grammar. It's relatively simple. We've got 4 productions. S produces AA, or the variable A, or S produces terminal A, and then A produces SA, and A produces B. So we've got just those 4 productions there. Now, the first thing we might notice is, well, first off, let's just go through the process. So step 1, convert that to Chomsky normal form. And you'll notice in this particular example, it already is in Chomsky normal form because capital S, variable producing variable, that's fine. Variable producing single terminal, that's fine. Variable producing variable, fine. Variable producing single terminal, fine. So this fits Chomsky normal form. So that is already in Chomsky normal form, so we're done with step 1. Super easy for step 1 with that one because it's already done. Now step 2 is where we relabel the variables. In this case, we've got 2 variables. We have S and we have A, so we need to relabel those. So S is going to become A1 and A is going to become A2. So now we have that order. Remember, we start with S. S is A1. Other variables we just list out A2, A3, A4. In this case, we only have A1 and A2 to worry about. And so now we're done with that. So the grammar after we do that substitution is going to look like this. So we had, and I've divided out the 4 productions here to make it easier to see them. So S produces AA. So S became A1. So A1 produces AA. Well, A became A2. So A1 produces A2. And then A1 produces A is the second part over here. And then after that, A2. So now we're on to A2 producing A1, A2, and A2 producing B. So now you'll notice we have all of them relabeled. We've rewritten our grammar with those new things relabeled. So now we're on to step 3. So step 3 is to manipulate the production so they're in, and eliminate the problem productions. In other words, a problem production is one of them that's not in one of those 3 forms that we saw earlier. So let's identify the problem productions. All right, so here are the 4 productions that we had from the previous step that came out of step 2. And so now what we want to do here is go through these one at a time and see if which of those are problem productions and which ones are okay. So this one, A1 produces A2. Does that fit one of these 3 forms? So let's look at this first form. A sub I, so we have 1 producing A sub j followed by 0 or more variables. So it seems to fit that, but let's check out the numbers. A1, A2. I is 1, j is 2. Well, is I less than j? Well, yes, 1 is less than 2, so that one's good. So that first production is okay. That's not a problem production. The second one. Let's check out the second one. Is that one okay? A1 produces A. Well, A1 produces A. AI produces A, something from our alphabet, alpha. Now this alpha is just a string of 0 or more variables. Well, 0 variables would be lambda. So this one is okay too. So that fits the second one of these. So that one's okay. Now we're on to the third one. A2 produces A1, A2. Now, that looks like this form here, but the J and the I are backwards. So that's a problem production. We're going to have to deal with that one. Let's just finish up the last one here before we deal with that one. A2 produces B. Well, that one fits the second form. A produces A followed by that, and that one is okay, just like this one up here was okay. So these, of those 4 productions, one of them turned out to be a problem. So we've got a problem production. We're going to need to address that. And that's one where the sequence was incorrect. So to get that into the right form, we're going to substitute the right-hand side of A1 in for A1 at the beginning of this. So this A1 is going to get substituted for all of the right-hand sides of A1. So the production for A1 looked like this. A1 produces A2, or A. So here are the right-hand sides. There are 2 of those. So we need to substitute both of those possibilities in for that. So the first one, we substitute in the A2. That gets substituted in for that. First A1, so now we get A2. And then the second one is substituting the A in for A2, and there's the second one down here. Notice I highlighted those in green to see where the thing substituted in for this A2. So now we get A2 produces A2, 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 and A2 also produces A2. Okay, now that new first one we created a new problem production though. Now we have a left recursion there, but this one's okay. This one fits the form that we had, the third form that we had, but this one has now introduced another problem. So now we need to eliminate the left recursion in that to fix that problem. All right, so to eliminate the left recursion from A2, here's what we have right now. So I've combined these two back together into one line. So we've got that and that. So remember how to eliminate left recursion. We've got to divide this up into the non-left recursive parts or productions and the left recursive ones. So the non-left recursive is this. Okay, let's just go through that. So here's what we're eliminating, the left recursive. And this B was left over. If you remember A2 producing B, we needed to introduce that back in because that was, let me go back a second. That was right there, A2 producing B. So we need to remember to put that back in, which we did there. So now to get rid of the left recursion from this left recursive variable A2, we have the non-left recursive ones, which are these two, and we have the left recursive one, which is that. So we divide those into the two categories, the non-left recursive ones, A2, and B, and the left recursive one, A2, A2, A2. Now the next thing we do is we identify those. These become the y's. The non-left recursive ones are y's. This becomes the x's are the left recursive part after the variable. And then we create that new variable, and this is non-left recursive part, non-left recursive part, new variable for all of those. So we get A2 followed and A2 Z2, which is our new variable we created, and then B and BZ2. And then Z2 becomes this non-left or the left recursive part after the variable. So in this case, A2, A2 or A2, A2, Z2. So same thing we've done before to remove left recursion. And again, the reason this works is because if you think about what's going on with left recursion, we're creating a chain of the left recursive things, eventually ending with a non-left recursive thing at the front. So we've just kind of reversed that chain and said, well, let's make the non-left recursive thing at the front, and then we can go into this Z2 part or skip it. If we go into the Z2 part, that's the part that's creating the chain of 0 more things. And what can it do? Well, it can make this thing and then stop, or it can make that thing and then make another link on the chain, another link on the chain, and so forth. So it makes sense how this works without necessarily memorizing it. That start off with the non-left recursive part that would terminate it at the beginning, and then enter a loop that could make 0 of those, or 1 or 2 or 3 or 4, eventually stopping with one of these things. Okay, so now we have that. So now we've got A1, and this is the full grammar again. So now we have A1 produces A2, A2, or A. And then we have A2, which we eliminated the left recursion from, doing these things that we just had over here. And then we have the new variable Z2 that was introduced to get rid of the left recursion, doing exactly what we had down here. So now all of those are in an acceptable form. They fit one of those forms we had. Notice lower number, bigger number. AI producing a terminal. Lower number, terminal, 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 terminal. These are all okay. They start with a single terminal and then only have variables afterwards. Now this one, Z2, that produces A2, but notice in this case this number is okay because this is the new variable. We're not having an A going to something with a lower number. Okay, so on to step 4. So step 4, remember we work backwards from A, and here there's a typo there. This needs to be A, N to A1. And we make sure that if it starts with a variable, we're going to do a substitution and plug things in to make sure we get a terminal first. So let's identify which ones of these need to have something done to them. So first one, we're starting at the end. I'm going to have to change this on several of these here. That's the problem with the typo on this. And here, I'm going to pause the video and then jump ahead and just fix a couple of these, and I'll be right back. Okay, we're back. And essentially what we are doing here is we're starting with AN, or starting at the end of this list and working our way backwards to the first. And that really, maybe they shouldn't say AN, it should say any of these things. So any of the productions working our way backwards from the number N down to 1, we're going to make sure we have a terminal first, and if there's not, then we're going to perform substitutions. So let's start at the bottom and let's work our way up. So this first production here, Z2, if we look on the right-hand side, A2, A2. Well, that doesn't have a terminal. So we're going to need to replace that. So that A2, we're going to replace it by substitution with all the right-hand sides of what A2 could have done on the right-hand side. Well, there's 4 possibilities there. So here are all the 4 substitutions. So A2, before that A2, or get substituted in, A2, Z2, B, A2, B, Z2. So all 4 of those possible right-hand sides substituting in for this A2 right there, giving us now these 4 productions. Z2 produces this, or that, or that. So this one production kind of ballooned out to 4 as we substituted all these things in for that. But now you'll notice all of these right-hand sides of the resulting one start with a single terminal and only consist of variables thereafter. So that's the first one. Now, there's another one. The other one for Z2 looks like this. Well, that started with a variable, so we've got to fix that. So to fix that, we're going to substitute all the things for A2 and for that. Again, 4 possibilities. Same 4 we had before. We just plug those in for that A2. And now at the end of that, this production now has all of these possibilities where those have all been substituted. But they all now start with a terminal and consist only of variables thereafter. So now we're getting pretty close. We fixed these 2. A2, all of those were okay. And if we work our way backwards to A1, we've only got one last production that starts with a variable, and that's this A1 produces A2, A2. So we're going to fix that one. So to fix that one we're going to do the same thing. It's that A2 that's at the beginning by substitution. The 4 possibilities for A2 get substituted in, and now we've got A1 producing all these, and there's our A left over at the end from that. All right, so now we're done, and the final grammar looks essentially like what we have here. So here it is all written out. And as a quick reminder of what it was like for the original looked like that. And the one that's in Greibach normal form looks like what we have on the side. And you'll notice, like, well, this maybe looks a lot simpler, at least a lot more concise than what we have over here. But you'll notice the advantage of this kind of the Greibach normal form thing that we had just created is that every right-hand side has a single terminal, which means that no matter what production I take, I'm always going to make progress through my input, and it's always going to be the first thing in the input that gets kind of consumed. And then we're going to move on to the next part, and the next part is going to have a single terminal. So in other words, this is a way that the grammar is kind of now linearized the processing, so it's always going to go in the order of the symbols as we see them coming up on the input. And you might ask, like, well, why do that? Why do we take this thing that looked fairly simple and turn it into something that looks more complex? But that kind of ability to linearize that, to say start with a terminal, match that, go on to the next level, match another terminal, match another terminal, match another terminal. In other words, kind of that sequential nature that we're matching these things or processing them can be really useful. And the main advantages to this Greibach normal form are obviously parsing. Something like predictive parsing could be aided by that, because a single terminal always appears first on the right-hand side. And not only that, but every application of a production, every step of a derivation with a grammar that's in Greibach normal form, every step of that derivation is going to essentially only match a single terminal before it moves on to the next part. So in other words, every step along this derivation is handling just one symbol. So we're kind of working our way through the input one symbol at a time. And that actually can be very useful as well for certain kinds of proofs, where you need to prove that you're going to process one symbol and then go on to the next symbol, on the next symbol. And in fact, the proof that proves that illustrates that every context-free grammar can be represented by a Turing machine. And a Turing machine is kind of a mathematical, another formal machine model kind of like a automaton. But Turing machines can represent anything that's computable. They can you can make a Turing machine that will essentially solve any problem that's computable, represent any language that's in the kind of Chomsky hierarchy of languages in that computable subset. And so how would you prove that a context-free grammar can be represented by one of those? Well, the proof involves making this thing in Greibach normal form, and then it has this nice feature of having linearized kind of that matching process, which is now nice on something that's like a Turing machine that can process a symbol. Go to the next step, process a symbol. So the Turing machine is simplified by putting the grammar in this form. And we know that this is always going to be finite still. There's going to be a finite number of productions. So this is, and the reason for that is because we sequentialized those and worked our way backwards with our substitutions. Eventually, we're going to get back down to A1. When we get to A1, the substitutions we did are guaranteed to then terminate because there's no way to have a cycle when the things are kind of organized in a sequential way like that. Okay, some final thoughts on Greibach normal form. We went through that pretty quickly. Feel free to go back and go through that example again. It makes a lot of sense. The process is really, it seems more complicated than it is. I mean, if I were to say, hey, turn this into that, you'd be like, well, what the hell, why, and how? But the process itself is actually pretty straightforward once you get used to it. But a couple thoughts on it. The resulting grammar that's in Greibach normal form has some useful properties. And those properties, every production only matches one terminal. So every step of a derivation will only ever match one single terminal before moving on to calling another variable or expanding another variable. And that single terminal always appears first, which means that we're going to process that string in kind of that linear fashion. And every context-free grammar, as long as lambda is not in as long as the empty string is not in that language, can be converted to a Greibach normal form. And also notice that the process for converting to GNF, to Greibach normal form, is algorithmic in nature, which means that you could make a program that you feed in a grammar, and it automatically converts it to GNF for you. So note that even though it seemed kind of tedious, it seemed like maybe you'd make mistakes, you can just automate the process and have an algorithm do it for you. An implementation of that is not particularly difficult to create. So that means we could put any context-free grammar into that algorithmic thing, and out of that process we'll merge a grammar in GNF that has that property. And again, one last thing here is really there's no other thing, but check out the study guide for the final exam. Be ready for the final exam. It's not during finals week like we originally intended. We're going to have it a little bit early. It's going to have everything we've covered up through Chomsky normal form. I'm not going to put a Greibach normal form question on the final, mainly because it takes time to go through and do all of those steps, and I want to make sure we emphasize the other stuff. And then after the final exam, I want you guys to, I want to finish some things up. I want to talk about pushdown automata, and I want to talk about Turing machines a little bit. So we're going to have two additional lectures after the final exam talking about those things. So your final exam is going to be next Monday, which will be Monday the 23rd. Oops. So be ready for that. And if you have any questions or anything, let me know. And also check out that study guide, because I'm going to post a study guide that has some samples. And if you do well in those samples and understand those, then you should do pretty well in the final. The final will be comprehensive. So all the stuff we did with regular expressions, DFA, NFA, conversions between them, that stuff will be fair game. But the final exam will emphasize a little more strongly the context-free grammars, manipulating context-free grammars, things along those lines. So look out for that. So that's it for today. And let me know if you have questions or need anything. And everybody stay safe.